Hello everyone, welcome back to Study Room. This is our next video lecture for chapter number 3. In this video lecture, we are going to study what? We are going to study the types of parallelograms. We have studied types of quadrilaterals, but now we are going to specifically study the types of parallelograms. So, what is a rhombus? A rhombus is a quadrilateral with sides of equal length. Since the opposite sides of a rhombus have the same length, it is also a parallelogram. So a rhombus has all the properties of a parallelogram and also that of a kite. So what is actually a rhombus? A rhombus is such a figure, is such a quadrilateral that has all the sides equal. So in rhombus, all sides are equal. And since it has opposite sides equal, so it is going to be a parallelogram, right? A rhombus is a parallelogram because if all the sides are equal, so the opposite sides are going to be equal, are bound to be equal. That is why rhombus is also a parallelogram. So we can say that a rhombus has the properties of a parallelogram. So all the properties that we have studied will be the same for a rhombus also, and that of a kite also, right? So the property of a rhombus is given to be the diagonals of a rhombus are perpendicular bisectors of one another, right? We have since all the other properties of a parallelogram is going to be bound to be true for a rhombus also, but one of the properties for a rhombus is that the diagonals of a rhombus are the perpendicular bisectors of one another. In parallelograms, we know that the diagonals are going to bisect each other at the point of intersection. So these are the bisectors, but for a rhombus, these are also the perpendicular bisectors. Perpendicular bisectors of one another. Now, what do we need to prove? See, we need to prove that angle AOC, this angle AOC is equal to COD, this angle, and these two angles are actually equal to how many degrees? These are equal to 90 degrees. That is perpendicular. These are perpendicular, right? Now proof. This is our proof that as rhombus is a parallelogram, therefore in triangle COD and in triangle AOC, AO is going to be equal to OD because these will be bisected here. This diagonal is going to be bisected here. Therefore AO is going to be OD. Since it is a parallelogram, diagonals of parallelogram bisect each other. And OC we have common to both these triangles. The third is AC equals to CD. AC is going to be CD equal to CD. Why? Because ABCD is actually a rhombus. And the sides, all the four sides of a rhombus are equal. Therefore, these sides are going to be equal. What can we say now? We can say that therefore this triangle COD is actually congruent to triangle AOC by SSS congruency criteria. Side. We have three sides. First of all, OC common, OC, AO equal to OD bisectors, and AC equal to CD because these are actually the sides of rhombus. Therefore, we can say, since these are congruent, we can say that angle AOC is equal to angle AOC is equal to angle COD. Now we have first of all proved that these angles are going to be equal. Now the next step is we need to prove that these angles are actually of 90 degree. We again know that since these two angles are equal, this angle equal to this angle, but they also form a linear pair. That is, the sum is going to be 180 degree. And these are equal, so only 90 degrees. So this is true only if these two angles are of 90 degrees. We can say that since they form a linear pair and they are equal, therefore they are of 90 degrees. So we have proved that these are perpendicular bisectors. Same we can prove for these two angles also by taking these two triangles and proving them congruent. And we have a rhombus given to us in this. RICE, rice is a rhombus given to us. We need to find X, Y and Z, and then we need to justify our findings also. Right, so here you can see that since RICE, this rice is a rhombus, it is also a parallelogram. And we know that these diagonals are going to bisect each other. Therefore, X is nothing but since X is equal to OE, OE is going to be equal to OI. And what is OI equal to? It is 5 cm. Therefore, X is nothing but is equal to 5 cm. So we have found out our X. Now similarly Y, y will be equal to 12. Why is y equal to 12? Because y is nothing but OR, and OR is going to be equal to OC because these are the perpendicular bisectors. For a rhombus, these are the perpendicular and also bisectors. So y will be equal to 12. Justification is that y is going to be this OC, because y is actually OR, it will be equal to OC because these diagonals are perpendicular bisectors. Same justification for x as well. Now z. So what is z? You can see in this figure z is actually Ri, and that is the side of one of the four sides of this rhombus. We know that all the sides of a rhombus are equal, so z is going to be the other side of the rhombus, that is z is going to be 13 centimeter because z is the side of the rhombus and all the sides of a rhombus are equal. So we have used all the properties for a rhombus and in order to find out x, y and z. Next we have another parallelogram, that is rectangle. A rectangle is a parallelogram with equal angles. Being a parallelogram, the rectangle has opposite sides of equal length and its diagonals bisect each other. So again, since rectangle is also a parallelogram, it has all the angles equal. So what is actually a rectangle? Rectangle is a parallelogram with all angles equal, not just opposite angles, but all the angles of the parallelogram, when they are equal, we can say that it is a rectangle. Now, being a parallelogram, rectangle has opposite sides of equal length, so these are going to be equal to each other, these are going to be equal to each other, right? Opposite sides are going to be equal, and the diagonals are going to bisect each other, right? These diagonals are going to bisect each other, equal to each other, right? Now, a property given to us for the rectangle is that every angle of a rectangle is of 90 degree. We know that all the angles of a rectangle are equal, but what these angles are equal to? What is their measure? They are of 90 degree. What is the proof for the same? Let the measure of each angle be x. Since all the angles for a rectangle are equal, we are letting all these angles to be x. We are letting all these angles to be x. Sum of interior, right? We know, we have already learned in another video lecture of ours that the sum of interior angles, is 360 degree. That is x plus x plus x plus x will be 360, that is 4x will be 360 degree. So 4x equals to 360 degree, then x will be 90 degree. So we have found out x, and that is 90 degree. So we can say that each angle of a rectangle is a right angle is 90 degree. So a rectangle is a parallelogram in which every angle is a right angle. This is the property. Another property for rectangles is that the diagonals of a rectangle are of equal length. Now we have learnt that for parallelogram and for rhombus also, for parallelogram the diagonals bisect each other. For rhombus, the diagonals are perpendicular bisector of each other. But for rectangles, the property that holds is that both the diagonals are also of equal length. So for rectangles, the property is that the diagonals are of equal length. The diagonals of a rectangle are of equal length. So what do we need to prove here? That this diagonal AC is equal to this diagonal BD. So what is the proof? See, for this triangle ABC and this triangle ADB, we are taking these two triangle ABC and ADB, we can say that AD is going to be equal to BC because these are the opposite sides of this rectangle. Opposite sides of rectangle AB and AB, this is common to both these triangles. And angle ABC, this angle ABC is equal to angle DAB, both are 90 degree. We have just proved this in our previous property. So we can say that both these triangles, triangle ABC is congruent to triangle ADB by SAS, side angle side congruency, where one side AB was common to AB, then we had this AD equal to BC because these were the opposite sides of rectangle, and another angle, this DAB is equal to angle ABC. Why? Because these two angles are the right angles, because these are the angles of rectangle. Hence, since these two triangles are congruent, we can say, therefore AC, we have said AC to be equal to BD. That is, these two diagonals of this rectangle are equal. So we have proved that the diagonals of a rectangle are of equal length. We have an example number 8. Rent, R-E-N-T, is given us to be a rectangle. Its diagonals are meeting at point O. Find x if OR equals to OR is given us to be 2x plus 4. What is OR? 2x plus 4. What is OT? OT is 3x plus 1. This OT is 3x plus 1. This OR is 2x plus 4. We need to find this value of this x. First of all, just have a look here that rent is nothing but a rectangle. We have just learnt this property that diagonals of a rectangle are equal. Therefore, since diagonals of a rectangle are going to be equal, that is, since Rn is going to be equal to DE, their halves are also going to be equal. Their halves, that is OR, is also going to be equal to OT, that are the halves of these two diagonals. These are nothing but the halves of these two diagonals. Why? Because we know that these diagonals also bisect each other and these diagonals are also equal. So if these diagonals are equal, their halves will also be equal. Therefore, the ROR was 2x plus 4. This is equal to OT, that was 3x plus 1. Now after solving this equation, we are getting 3x minus 2x is equal to 4 minus 1. That is, our x is equal to 4 minus 1, 3. This is what we had to find. We had to find the value of x and our x is equal to 3. How did we find it? We found out this value of x by using this property that the diagonals of a rectangle are of equal length. Next parallelogram that we have is a square. What is a square? A square is also a type of rectangle, right? A square is also a rectangle but with all the sides equal. With equal sides. A rectangle with equal sides is a square. This means a square has all the properties of a rectangle. Right? All the properties that we learnt of a rectangle are going to be true for a square also, with an additional requirement that all the sides have equal length, right? All the properties of this rectangle will be true for square also, but for a square, all the sides will have equal length. The square, like the rectangle, has diagonals of equal length. Since rectangle had these diagonals of equal length, so square is also a type of rectangle with all sides equal, so it will also have the diagonals are equal. We have this puzzle now. How many squares are there? Just take your time and find that how many squares are here in this figure. How many squares are we having? Let's find it out. So first of all, we know that this whole box is actually a square. This is actually a square that is given to us. So 1 is this big square. This is a square. This smaller one is a square. This is also a square. This is also a square. This is also a square. So 4 these and this bigger one, 5 total. But now if you see that if we add these two squares, is this going to be a square? No, this is coming to be a rectangle and not a square. Similarly, if we add these two, again this is not a square. These two not a square. These two not a square. So these are all the figures that we were able to find out. But these adding two smaller squares is giving us a rectangle and not a square. So in total, how many squares are there? There are total 5 squares, bigger one and the 4 smaller ones. So 5 squares are there in this puzzle. Now we are going to study about the properties of square. In a square, the diagonals bisect one another. Because square is a parallelogram, so we can say that the diagonals bisect one another. Because square is a rectangle, so we can say that diagonals are of equal length. Why? Because square is also a type of rectangle. And these diagonals are perpendicular to one another. What? These diagonals are perpendicular to one another. These are perpendicular bisectors of one another having equal lengths. These are some of the properties of the diagonals of a square. Another property for a square is that the diagonals of a square are perpendicular bisector of each other. We have just read it from here that these are perpendicular to one another and bisect each other and are of equal length. We are going to prove this, that the diagonals of a square are perpendicular bisector of each other. That is, we need to prove that this angle AOC and this angle COD both are 90 degrees. Both are 90 degrees. Both are right angles. What is our proof? Here the proof given to us is that as square is a parallelogram, we know that square is actually a type of parallelogram. In this triangle COD and in this triangle AOC, we will have AO equal to OD. Because it is a parallelogram, so the diagonals are going to bisect each other, therefore AO is going to be equal to OD. Diagonals of a parallelogram bisect each other. Now you can see in these two triangles, this OC is common to both. Therefore OC equals to OC common. And last is AC equals to CD. Why? Because these are the sides of the square and all the sides of a square are equal. Therefore AC equals to CD. So we can say therefore that triangle COD, this triangle COD is congruent to triangle AOC by SSS, triple S congruency criteria, side, side, side. One side was OC common, one was AO equal to OD, perpendicular bisectors, bisectors. So parallelogram, diagonals bisect each other, right? And one was AC equal to CD because these are actually the sides, two sides of a square. Therefore, since these two triangles are congruent to each other, we can say that angle AOC is equal to angle COD. Now we have proved that these two angles are equal. At last we need to prove that these are perpendicular. These are of 90 degree right angles. Now you can see that these are nothing but they form a linear pair. That is, their sum is going to be 180 degree. They are equal and their sum is 180 degrees. So we can directly say this is true only if these two angles are right angles. That is, if they are 90 degrees. So we have proved that the diagonals for a square are perpendicular bisectors. This was all about our video lecture in which we have learned about the types of parallelograms and then the properties for all those types of the parallelogram. We also did some examples. So we have one more video lecture for this chapter. We'll connect in the last video where we are going to do a quick revision for all the topics. We'll meet next time. Thank you.